Welcome to this video. In this video, I'll be teaching on how to decompose a partial fraction, or how to express a composed fraction into a partial fraction. All right. So I've picked one example here, which says express the following as a partial fraction. Okay. So we have 3x plus 5 over open brackets x plus 1 close brackets open brackets again, x plus 2 close brackets open brackets again, x plus 3 close brackets. How do we decompose this fraction, or how do we make this fraction as a partial fraction? Okay, so what it is basically we're just trying to say how was this fraction before it became a composed fraction into individual fractions from which it became this. So we are going to separate this into 3 parts based on the denominators there. There are 3 denominators there. All right. So we are going to say the first one will be A plus the second one will be B with its denominator. So this will be the B part, and the denominator for B will be x plus 2. And then I have a C part. The C part will be C there, and the denominator is x plus 3. I'm getting these denominators here, these ones there. Okay, so x plus 3. So we know where the denominators are coming from. They are coming from the bottom parts there, those numbers. Okay, so now I've done the first part, which is basically to separate. Okay, now the first thing that we're going to do is to multiply. I've equated this to that, and the first thing that I'm going to do is to multiply both sides of the fraction, multiply by the denominator there, the bottom denominator. Okay, so now what is going to happen here is I'll pick this. I'll pick that, and then I need to multiply it with the bottom part, this bottom part. So I'll multiply both sides with the bottom part. Again, this same thing being multiplied by the other side of the equation. Okay, so maybe I can reduce to that was 15. I can reduce to 12. I see. Okay, I don't know what I did. I can reduce this to 12. I see if it will fit. Yes, it has fitted. All right. So now mathematically, if you are multiplying this side by that, the bottom part here is basically the same as that part. All right. So these two will technically cancel because this is as good as it's over 1. Let me express it in that manner so there is no confusion. All right, so let me do it like that. It's okay. So now this whole part will cancel with the other yellow part, the bottom part. Will only remain with the top part, which have been indicated in green. So we are only going to remain with 3x plus 5 this side. We're going to remain with 3x plus 5 this side. Okay? Then we shall say equal to. Now, I'll demonstrate what I'm going to do to A, and then that will be true to B, and that will be the same to C. So let me see if I can demonstrate. If I multiply A, this first part, A, multiply by that whole part here. Okay, so if I multiply A with this whole part here, just A alone, the part for A, this will look like this. Let me demonstrate here. So that we are on the same page. Let me demonstrate here. So if I multiply this part, the A part, with that part, you will see that the denominator here, which is the bottom part, there is the same as this first number here. So what these two will do, they will cancel, and then it will just be A. It will just be A multiplying by that. So this technically will look like this. Because this and that will cancel, then it will just be A multiplied by open brackets x1 plus 2 close brackets, open brackets x plus 3 close brackets. So meaning this will disappear, and most likely the bottom part, let me just do this. And then we'll have the A there, and then we'll have the A there. And then we'll say plus, okay? In the same manner, B here, if you see the bottom part for B is that, meaning this and that will cancel. Will only remain with B, open brackets, x plus 1 close brackets, open brackets again, x plus 3 close brackets, because that part has cancelled with that. In the same manner, as we go to C, I'll write C there. The denominator for C, which is this one, x plus 3 x plus 3 there, they will cancel. So I'll only remain with x plus 1 multiplied by x plus 2. These ones here. So I've open brackets, x plus 1, close brackets, open brackets, x plus 2. All right. Now in this way, we can proceed. Okay. So how do we get to proceed here? Each one of the denominators here, we'll try to make it a 0. Okay. So I'll start with the first one here. Those inner numbers, if I want to make them a 0, I need to make x negative 2 because it's x plus 2. So when I say negative 2 plus 2, it will give me a 0. So I'll need to place x to allow it to be negative 2. In the same manner, I'll come on the other one here where I'll make 3 to be I'll come here, I can come here where I'll make even 1 to be a negative at some point, so that I obtain a 0 here, and then I'll come at the part where I'll also make 3 to be a 0 and something like that. So for now, I shall say let x be negative 2, because I'm trying to eliminate these 2 here. I'm trying to eliminate that 2 there, such that if I bring this whole equation here, here where there is x, I shall put negative 2, close brackets. Here where there is x, I shall put negative 2, negative 2. Everywhere where there is x, I'm putting negative 2. Now, technically, when we say 3 multiplied by negative 2, of course, we obtain negative 6 plus 5. This part here plus 5. We are obtaining actually negative 1. We're obtaining actually negative 1. And now, when you look at here, on the first one here, negative 2 plus 2 will give us 0. So everything here will be multiplied by 0, which will become a 0. So that one is mathematically out. All right? Again, when we are here, when we say negative 2 plus 1, that one will give us negative 1. Multiplied by negative 2 plus 3, that one will give us 1. So basically, when we multiply, we say open brackets, negative 2 plus 1, open brackets again, negative 2, negative 2 plus 3. Mathematically, it's giving us negative 1. Negative 1 multiplied by b, this shall be negative 1b, which is as good as negative b. Okay. Now we are finding for b. So if we are finding for b here, we shall divide both sides by negatives. So I have negative b here, divided by negative 1 is equal to, let me do that so that it's clear. Again, I have negative 1 divided by negative 1. All right. So we can conclude here to say b is actually equal to 1, because negative b divided by negative 1, it will give us b. Then negative 1 divided by negative 1, it will give us 1. So b is actually equal to 1. All right. Let me come the other side. You remember I said in each of the expressions here on my right hand side, I'll indicate my right hand side. Let me then put these in bold. On my right hand side, this side, I'll try by all means to make everything which has letter A, B, C 0 at some point. So I'm trying to make now X. I want to make that one a 0. I want to make this one a 0. So what I'm going to do is I'll say let X be equal to -1. So that when I place X here, which is -1 plus 1, it will give me a 0 here. All right. So I'll say let X be using Arial, sorry. Let X be -1. So where there is X in this whole expression, I'll put -1. -1 there. -1 here. -1 here. -1 here. -1 there. -1 there. And -1 there. All right. So 3 multiplied by -1, that would be -1. That would be -3. 3 multiplied by -1, that would be -3. -3 plus 5, that would be +2. I shall have the 2 here. I shall have the 2 there. And then in A there, let's see -1 here. -1 plus 1 or plus 2. -1 plus 2 will be 1. -1 plus 2 will be 1. Multiplied by -1 plus 3, which will be 2. And this gives me 2. So I have 2A here. All right. Technically, when you see here, just that expression, it will be -1 plus 1, which will give us a 0. 0 multiplied by B will be 0. 0 multiplied by the other part here will be 0. So meaning, as long as one of the guys here is going to be 0, it will make everything 0 because we're going to multiply everything by 0. In the same manner here, where they see, they are seeing that there's that negative and that one. And then technically, because of the 0 there, everything which will be multiplied by that will be a 0. Okay. So now here we are solving for A, meaning we are going to divide both sides by A. So if we divide both sides by A, 2A divided by A, it will be A. 2 divided by 2 will be 2. We are going to divide, we are solving for A, we are going to divide both sides by 2, not A, sorry for that. We're going to divide both sides by 2. So 2A divided by 2 will be A, which is that one. 2 divided by 2 will be 1. So A is equal to 1. All right. We are remaining with the last one, which is going to be C. So we can simply say let X be -3. All right. We've dealt with A being -1, B -2. Now we are saying let X be -3. Let X be -3 so that I can remain with a C there where there is no -3. I can render this one 0 and this one 0 so that I can solve for C. Okay. So let X be -3. Let x be negative 3. Let's see if we throw it in that expression. What will it be? Here we are. There I put negative 3. Where there is x, I'm putting 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 negative 3. Negative 3 there. Negative 3 here. And negative 3 there. Okay? Negative 3 multiplied by positive 3, that will be negative 9. Negative 9. Negative 9 plus 5 will give me negative 4. So I have negative 4 this side being equal to okay, I won't waste much time. Here there is a negative 3 and positive 3, meaning this will be rendered to 0, and 0 will multiply with everything in this part, which will make everything a 0. Okay, and also here there is a negative 3 and positive 3, which will make it a 0, and everything multiplied by 0 will be a 0. Now here there is something new. We have negative 3 plus 1. Negative 3 plus 1 will give us negative 2. Multiply by negative 3 plus 2, which gives us a negative 3 plus 2, which gives us negative 1. Negative 1 multiplied by negative 2, which we found here, it shall be 2. Okay, so when we say open brackets, negative 3 plus 1 close brackets, multiplied by open brackets, negative 3 plus 2, it's giving us 2. So we have 2c here. Here, and we are solving for 2. We are solving for c, I mean. So we'll divide both sides by 2. 2c divided by 2, that will be c. Negative 4 divided by 2, that will be negative 2. There we go. We found all the numbers, and then we can safely say we found the decomposition of the partial fraction, which is this one. So we've decomposed a fraction which was composed. We've made it a partial fraction. So here we are. I'm bringing it here. Remember what I said? This is how it shall look like. Therefore, the final answer will be where there is a there. A, we found 1. As you can see here, where there is a there, I'm putting 1. And where there is b, what was b? B, we also found 1. It's here. So where there is b, I'm putting 1. C, we found negative 2. It's here. So where there is c, I'm putting negative 2. That's the final answer. That's how you decompose a partial fraction. Now, I can safely say when we deal with this, it brings us back to the original function, which is that. Let me prove that quickly before I end this video. Let me find the answer for this so that it takes us back. But if the examiner asks you to find the partial fraction, the final answer is this one. I'm only trying to prove mathematically to say we decomposed something which we can take back by actually simplifying it or solving it. Let's see how this goes. Quickly, we have that. Okay. And if we are finding like this, we can safely say we have the common denominator will be this, multiplied by that, multiplied by that. So we can safely say we have 1 plus 1 minus 2. Those top ones, 1 plus 1 minus 2. Okay, over open brackets 1 plus x plus 1, and then again x plus 2, and again x plus 3. We have that. Okay, so how do we do this? I'm sure by now we are all aware how this goes. We are all aware how this goes. So how do we manage this? Since the first one has that, this one will be gotten rid of. So the 1 will be multiplied by these two numbers here. Okay? While else we maintain the denominator. We know how to deal with fractions. So this one will be multiplied by these two, because the 1 will go into 1 there. I can copy that. Press it here. Yes. I'm demonstrating. So the first part of 1 here will be multiplied by these two. Okay? Meaning the second part of 1 will be multiplied by, we will exclude this one, which I'll put in green. Meaning it will be multiplied by x1 and x3. The second part there will be multiplied by that. X1 here and x3, yes. The second one there will be multiplied by that. And the last one will be multiplied by the first two here. We know why we are doing this, because this and that, they'll definitely cancel. You know how to operate fractions. I'm just trying to prove, and I need to be quick here, because this was not part of the main solution that I'm looking for. I'm only doing this for our understanding, so that we can understand. Yes, so that's what we obtain. And then we are going to expand this. Okay. We're going to expand that. How do we expand? Let's see. X in here multiplied by the x in there will give us x squared. So now I'm expanding. Okay. Then x in here multiplied by 3. I'm sure you know how to do those ones. Will give us plus 3x. We are shifting, we are coming to the 2. 2 multiplied by x there, it will be 2x. So plus 2x. Two here multiplied by 3 there, it shall be 6. So plus 6. Now that I've shown how to expand and you know how to expand, I'll go on and expand them. So in here, it will be like this. I'll go on and expand them. X multiplied by x there, that will be x squared for the second part. And then x multiplied by 3, that will be plus 3x. And then I shift to 1 here. 1 multiplied by x, that shall be x. Or others will call it 1x. Then 1 multiplied by 3, that shall be 3. I'm expanding on the last part. X multiplied by x, it shall be x squared. X multiplied by 2, 2x. One multiplied by x, x. 1 multiplied by 2, 2, like that. Okay. Now quickly, let me demolish this so that we have the final answer here, or not the answer, we're just proving actually. 1 multiplied by this, it shall be itself. So the one will go there. We'll remain with that. Okay. Trying to be stubborn. Negative 2 multiplied by that. That will be negative 2x squared. Negative 2x squared. Negative 2 multiplied by 2 there. I'm multiplying this, multiplied by that. That will be negative 4. And then negative 2 multiplied by x, it will be negative 2x. Negative 2 multiplied by 2, it will be negative 4. So we have these things here where we're going to remove some okay, they are stubborn. I'll leave them then. Okay, so let's deal with the numbers here. Let's deal with the numbers. Okay. Yeah, let's do the numbers. I'll do them directly. There is no harm. Thank you. I'll do them directly. X squared here plus x squared there. That is 2x squared minus 2x squared there. That will be 0. So I've dealt with the x squared. X squared here plus x squared there. 2x squared minus 2x squared, 0. Okay. Yes, that's 0. And then I need to get now. Let me remove the top part so that I can be putting numbers here. Yes. So that's 0. Then I'm going to the x. 3x plus 2x, that's 5x. 5x plus 3x, that's 8x. 8x minus 4x. 8x minus 4x, that's yes. So this is let me begin again. 3x plus 2x, 5x. 5x plus 3x, 8x. 8x minus 4x, that is 4x. That is 4x. And then 4x. Somewhere there's a mistake. Okay, let me double check quickly. Yeah, 3x plus 2x, that's 5x. Okay, 3x plus 2x, that's 5x, plus 3x again, that's 8x, plus x, that is 9x, minus 4x, that is 5x, minus 2x, that is 3x. Okay, so just dealing with these ones, this plus that, plus that, plus that, minus that, minus that, and it gives me 3x. So 3x here. Okay, numbers now. 6 plus 3, that is 9. 9 minus 4, that is 5. So plus 5. Okay, what does this mean? It has brought us to the original equation. I stressed this far just to show you to say these decomposed partial fraction, when we compose them back, they bring us back to 3x plus 5 over open bracket x plus 1 close brackets open brackets x plus 2 close brackets open brackets x plus 3, which is this number below here, there. So what does this mean? Did you need this as part of your answer? This part I'm putting in green? No. What was I doing? I was just trying to prove to you that when we do this, we get back to the original expression or fraction, which is that, which we decomposed into A, B, C, and we found the values of A. So therefore, having said that, the final answer for your decomposition of the fraction is that this one in yellow, where you placed, where there is A, you found A to be 1, and B, you found it to be 1, and C, you find it to be -2. Thank you so very much. Subscribe to my YouTube channel to enjoy more videos.